important tool we are going to discuss today morning. So before that, hope you all remember the define phase, right? The purpose of the define phase is problem understanding, right? Thoroughly understand the problem and identify the process for improvement and form the team, set clear target and get our project charter approved. Once project charter is approved, define phase is over. And then we move on to measure phase. So the purpose of measure phase is to verify the problem validity and also understand the baseline. We need to understand the baseline performance, and baseline can be understood using different tools. Like DPMO is one such tool, your PPM is another tool, yield is another tool, and CP and CPK. There is one more tool known as CP and CPK. So that is what we are going to discuss right now. So any of you here, do you have the idea about CP, CPK? Are you using it in your current job, in your current process? Anybody here using CP and CPK?
No, sir.
Yes, sir. Process capability and process capability index.
Very good. So very good process capability ratio and process capability index. Fantastic. So which company are you working, Manikandan? It's a manufacturing or service?
Manufacturing, sir.
Okay, in manufacturing company. You are studying CP and CPK for
Yes.
what characteristics? Is it a dimensional characteristics or material characteristics?
Attribute and also a variable dimension and also go no go attribute.
Attribute means what kind of attributes? Can you give an example?
Thread packages, go no go. Yes, injected in threads.
Are you using CPCPK for that also? Go no go gauge type measurements?
No, sir.
No.
Only for variables.
Very good. So that's the point. So CP and CPK can be used only for variable characteristics like dimension. We studied data type as continuous data. The moment you understand your data type is continuous, you can use CP and CPK, right?
Yes, sir.
So yeah. And in order to calculate CP and CPK, you must have a clarity on specification limits. Must have
Yes.
a clarity on specification limits. Specification limits are normally given by the customer. And you should also be able to understand your, the process statistics. Process statistics are nothing but there are two important statistics we are always interested in. One is process average. The other one is process standard deviation. One is process average. The other one is process standard deviation. And also the quality of your study depends on, the amount of effort you put into calculate the CP and CPK. The first thing is the quality of the data. First thing is quality of the data. Your data should be free from measurement error. Hope all of you know what is measurement error, right? We talked about gauge R&R. We talked about, bias. So if your measurement system has problems or your people don't know how to measure and they make a lot of measurement error, then what will happen? The capability, whatever you study, will not be the real capability, right? You might think that your process is highly capable, but in reality, there could be a lot of customer dissatisfaction happening. So if you really wanted to avoid all of this, you must make sure data is collected with extreme care and without any measurement error. Another point to understand is the quantum of data. How much data you are collecting. And here the rule is the more is better. Hope all of you also agree with me on this, right? The more the data, the better will be the understanding. So this is called a data collection plan. The duration of your data collection. Are you collecting the data in a single day? Are you collecting the data spread over a period of 1 week? Or are you collecting the data spread over a period of 2 weeks? Or are you collecting the data spread over a period of 1 month, right? So what do you think? Which is better? Collecting the data just in 1 day is fine, or do you want to collect data over a period of time? Which is a better approach? Come on.
Taking more time. Harish.
Period of time, sir.
Yeah, data collected over a period of time. Why do we spread the data collection period? Any idea? Why should we spread it? Why not we simply collect all the data in just half an hour and then do the study? Why should we spread it?
But half an hour variation only will show.
Very good. If you collect the data in just half an hour, and within half an hour, whatever variation your process goes through, right? And that will get captured. If the variation happens, any variation that happens outside this data collected period will not be captured in your data. All of you agree with me? Do you understand what I'm speaking?
Yes, sir.
So you must have an idea about how much duration is sufficient enough to capture the variation our process might undergo, right? Our process will be influenced by the variation. So can you tell me what are all the kinds of variation, possible variations? What are the variations possible? Do you have shift to variation?
Man variation, shift to shift.
Yeah, variation, operator to operator variation,
Page
shift to
variation.
shift variation, machine to machine variation, line to line variation, day to day variation, week to week variation. You just have to ask yourself, what are all the variations that are currently affecting your process? If your process is also affected based on the week, then collecting data for just a few days will not at all be sufficient. Isn't it? Why there is a week to week variation? Tell me why there is a week to week. See, for our training program also last week, the attendance was great, but now attendance is poor. There is a big variation week to week. Isn't it? So what could be the reason? Can you tell me some possible reason why there is a variation? See, clear difference between performance in the last week and this week. What could be a reason? Tell me, all of you.
Yeah, they are busy with some other works.
Okay, our people's absence. Okay, I'm asking about our company scenario. In a company scenario, when we are actually manufacturing a product, and if you notice a variation, abnormal variation from past week and this week, what could be the reason?
So there is a shift change in process, and who are working in night shift, they come to in day shift. So if the efficiency of the day shift workers and night shift workers are different, there is a difference in week to week.
Okay, so that you can capture within a day. Within a day, because in every day you have shift to shift, shifts are changing. So if you simply compare first shift data with second shift data, then you come to know. Now I'm talking something at a bigger level. Last week data and compared with this week data, there is a variation. What could have been the reason?
The tool life determination.
Wow, beautiful. Sir Nayan is giving a fantastic input. Sir, the tool has won out by once you use it for 7 days, then there is a tool won out that can happen. So you have to change the tool once in 7 days. That is your point. Am I correct?
Correct, sir. Correct.
So if you want to capture the variation due to tool won out, you can't capture that in just by studying for a day. Hope all of you understand. Because in a day, nothing happens for the tool. We very well know. But when we study it for at least 2 weeks time, then definitely there will be a tool change, isn't it? And tool in the fresh condition and tool in the worn out condition and all those things will start happening. That is why it is very important to spread your data collection. And to what extent you need to spread? You must have the process knowledge. Like Nayan was saying, yes, sir, tool one out can happen in 3 days' time, 4 days' time, in 7 days' time, in 10 days' time. Similarly, do you think the raw material, the inventory is also available only for, let's say, 5 days? Then once in 5 days, the raw material the raw material has to be replenished, isn't it? There will be a change in the raw material.
There will be rust. There will be a change of with alloy of raw materials may change
Correct.
from the suppliers.
Okay. So due to storage, something can go wrong, and also the fresh raw material comes. There can be a difference in the raw material characteristics. All of these things are going to affect your process performance. And so you should be able to capture all of them. If you are not capturing all of them, you will not be able to understand the realistic capability of your process. All of you are with me on this? Many a time people get confused here. They simply ask, sir, how much data is sufficient? It's not just how much data, your spread of your data collection also matters. Let us say a company has very strong control over, all these long-term variation. Let's say raw material characteristics, there is a strict incoming material quality check. Do you understand? There is a strict incoming material quality check. And there is also a check for tool wear. For the same situation I'm saying, tool wear once in 4 hours, they are checking. And even before the tool could worn out, they could get signals and replace the tool. Now, what the company is trying to do, can somebody tell me? If they are checking every 4 hours, they are checking the tool condition. And also, they have a strong incoming material check. What the company is trying to do? Why are we having the incoming check? Come on. What is the reason? Incoming inspection.
Maintaining proper quality of the product.
Proper quality. That means you don't want variation. If there is a variation, you want to reject there itself. As a result, variation cannot come and affect your process. If you have such effective control, then you can reduce the spread of your data collection. All of you, do you understand? Such companies don't have to collect data for 15 days. They can just collect data for, short period of time. Again, it depends on the process understanding. Let's say for just 2 days, 3 days, even 2 days, 3 days data can give a realistic estimate of the capability. Whether they study for 3 days or study for 30 days, they'll get same CP and CPK. All of you, do you understand what I'm speaking? If you have effective control, right? At least, all the variations are prevented at the source itself. So such process, when you monitor using a control chart, you will see the control chart, all the points always appearing inside the control limit. If all the points are appearing inside the control limit, that means you have effective control over the process, and hence the spread of data collection can be minimized. Otherwise, you have to stick to the rule, more is better. Whatever is possible, you please collect. Right? Because we don't know what will happen. After 5 days, there is a problem with the raw material. After 10 days, there is a problem with the tool. Right? So if these things are there, then you must necessarily have to ensure your data collection period is larger than the 5 days or 10 days period. Then only the variation will get captured. All right. So once you understand about the quality as well as the quantum of the data, importance of it, yes, you will definitely be able to get a realistic measure of the capability. And one more point to understand is, now that you decided to collect data for, let's say, 1 week, you also decide to collect data from every single shift. Day shift also, second shift also, night shift also. You must have logic for all of this. Am I correct? Why are we collecting data from all the shift? Because we want to know the quality of each and every shift, right? And then within the particular shift, so different companies follow different tactics to collect the data. Some companies, they collect data just only one time in a shift. Only once in a shift. So what is their idea? They know that their control within that shift time is very high. So no, they don't have to collect data frequently. Throughout the shift, how many times they just have to take the data? Only once. All of you, do you understand? But if you are very, very clear that the chances of things going out of control is very high, let's say after 1 hour, the process can deteriorate because maybe the machine settings, every 1 hour the machine setting can automatically change because the machines are old. Under such situation, do you think selecting just one sample in a shift can help you to understand the real capability? Machines are very old. So what happens? Every 1 hour, situations are becoming worse and worse. In such a situation, tell me, how will you collect data? A shift means 8 hours. Come on, guys, please speak out. You need to speak now. Otherwise, you will definitely have a problem here. And then you will come out to be like the ordinary Six Sigma belts. This is where people, struggle. So if the machines are old, if the sources of variations are, dominating in every single hour, then how should you collect data? Tell me.
We have to collect data in full shift.
Through full shift, right?
Yeah, 8 hours.
Yeah, very frequently you have to collect data.
Yes.
Maybe hourly once. That means within a shift, 8 times you have to go and collect data. Yes, now there is a comment in the chat box. Sir, there is a power supply. Oh, if there is a power supply comes, yes, that should also be, considered. And then probably you may have to collect data to understand, the effect of the power supply also. If you don't collect data, you will not understand anything. So ultimately, more than the subject knowledge, it is the common sense that is going to guide you. How many of you agree with me? Your own understanding and the process. If you simply read some book and then follow the procedure, the book is written with some assumptions. If those assumptions are not getting fulfilled in your shop floor, and there is no point of following that formula or that recommendation, you have to make your own recommendation and then, try to get the best information. All right. But let us imagine a very healthy scenario. A company has a strong process, machines maintained in very good condition, operators are, properly skilled, and they are very disciplined to follow the SOP. If everything is, in place, in control, if you plot a control chart, you will see an excellent control in the control chart is demonstrating. All your points are always inside the control limit, and exactly majority of the points will be towards the center line. Only very few points will be towards the control limit. So these are indications that your process is under a state of statistical control. In control phase, we'll talk about control chart also. If this is happening, yes, just collect only one sample in a shift, just to understand what's happening. Just to understand what's happening. In all other situations, you have to, take more samples. Another point. Okay, you decided to take one sample per shift. One sample not always means just one piece. No. It can be multiple units. It is always a good idea to select multiple samples and calculate an average out of it and try to have control over the average, not on the individual data. All of you understand what I'm speaking? Always try to have control over the average, because if you are able to control the average, it means majority of the parts you produce, you will be able to judge accurately. You will be able to judge accurately, isn't it? Say, for example, you want to know how your kids are studying in the school. Would you like to randomly just ask one school teacher about how your kid is studying? Or do you want to ask all the teachers? Tell me.
All the
All
the teachers, because there are different subjects. Isn't it? If I simply look at the language subject, my child is very strong in language. But maybe weak in mathematics. I will not come to know. I will not know if I only talk to the language teacher. And then they all will say the kid is very great in studies. But actually in mathematics, it is very poor. At the same time, what are we interested in? We are interested in seeing that our kid performs well in all the subject. If your kid performs well in all the subject, not only the individual marks will be good, the average mark will also be good. Yes or no? What is the
Yes.
average in the quarterly exam? And what is the average in the half-yearly exam? You are putting a condition to your child. Average should increase at least 5% every exam. Isn't it? And now
Yes.
an all-round performance is needed to improve on the average. So that's why it is always a good idea to take multiple samples. If any of you are collecting, just picking one sample and then doing everything out of it, try to avoid it. But if there is no other option, you have to do it. Like it's a destructive testing. The sampling is very costlier. Study is very costlier. In all those situations, I agree. Because companies cannot afford, the money spent on the testing and all. Isn't it? Let's say it's a destructive testing. One component is 10,000 rupees. And do you think company will afford to destruct 10 pieces at a time? No. Simply we are destructing 1 lakh. So there are certain situations where sampling could be very costlier, or it is very laborious, very time consuming. So there is a clear requirement to reduce the sample size. That's an exceptional case. Go with the sample size of 1. All of you understand when to go for a sample size of 1. This is actually known as subgroup size. This is actually known as subgroup size. At a time, how many sample you are taking? That is known as subgroup size. If subgroup size is 1, that's one thing. But in all other scenario, at least take 2 samples at a time. If you can take 3, much better. If you can take 4, much more better. If you can take 5, fantastic. If you can take 10, fabulous. Do you understand, all of you? Because ultimately, you want to understand what's happening in the shop floor, yes or no? And you can't stay there 24/7. How much time you are there? You are there only for 8 hours. But remaining 16 hours, what happens? You understand only by looking at the data. That's why giving importance to the data is very important. So what actually affects your capability measures? The quality and the quantum of data. All of you understand?
Yes, sir.
Quality of the
Yes,
data.
sir.
Another thing is quantum of data. Quality of the data depends on the measurement system. The measurement system is very poor. People don't know how to use the vernier caliper, don't know how to use the dial gauge, or they have a very poorly calibrated dial gauge. Measurement system is useless. Quality is lost. Another thing is quantum of data. Period of data collection, particularly the spread. Another thing is subgroup size. The maximum number of subgroup size needed is, if you select the spread properly, the maximum number of samples in a subgroup is 25 only. Maximum is how many? 25.
25.
As you gain more and more control, you can bring down that number from 25 to 20, 20 to 15, 15 to 10, 10 to 5, and probably you can stop with 3. No, I think 5 itself is a manageable number. All of you agree with me on this?
Yes, sir.
5
Yes.
is a manageable number, right? But this is how you must bring down the sample size. Not just like that. If you are doing it, it's a trial and error approach. So it takes some time to study and then understand, and then and all of this knowledge should be available in your control plan, which you will be developing in the control phase. In your absence, people should collect the data the way you have recommended. Then only all the estimates will be correct. Then only there will be less of argument between you and your clients, you and your team members. If you don't follow all of this, most of the time there will be argument. You will send one report and they will not agree. You will dispatch the lot and they will return the lot. All of these things will happen, and to avoid that, you have to be extremely careful on this subject, right? Hope the idea is clear. And now we are now going to understand what CP/CPK are. How are they calculated, right? The little theory behind. And then why it should be 1.67. Why not it is, if it is less than 1, what it means. If it is more than 1, what it means. More than 1 is enough. But why 1.33 is demanded? Why 1.67 is demanded? And what's the difference between CP and then CPK? That is going to be our learning for the next 1 hour. Is that clear, all of you? All of you are ready?